Wow, that's what I call a cliffhanger, I guess. And as we see, it didn't work because I put in some weird error there. I wanted to return foo, but it should be a string and not some undeclared, undefined name there. So the test worked. It showed me that I did a mistake, and fair enough. Let's just jump right back here. I have many files open, too many for the show with these, but anyway, that's normal. That's kind of a normal window. So I'm fixing my issue here. Now return a string, which is foo. Back to test base and no types, and yeah, let's just rerun it. And as we learned before, 2011 is not the fastest to use. We should better use my 8.5, for example. Okay, so now my test works. Oops. And I just verified that my feature appears to be correct. And this simple function, this simple signature, I don't necessarily need to do more. So that's pretty okay. More complex signatures will force you to do more complex testing on it, perhaps write loops around it, try it with all kind, try the boundary situations of your method, make sure it really throws the exceptions that you have documented within your doc strings. Things like this you would definitely check here. So check the corners of your functions to be sure this is right and the documentation matches. Just to recap, this is how it usually started. I started writing the documentation. So in this case, it really is not much to say about it, but usually writing the documentation really helps to learn what you really want to do with that function. And writing a test case for this, perhaps even before you write the actual function, helps you to figure out how you want to use that function. So in my case, it's pretty clear, but the question is, and it's, why do I have to instantiate, or why do I have to get a real node if this foo method is always returning foo? So I don't need instance data for this at all. So I could say, well, I change the design and make this a class method. And this would be class then. And it's foo. So now I don't need an instance anymore. Although I can use an instance. So this works, this still works. But also, anti-node foo will now work. So that's our new design here, which is kind of more flexible because it's easier to use. The data that you return. Yes. So what I did here, I used the node. Node is the fundamental, the base class for all dependency nodes, for instance. And of course, I didn't add the function there. I did it somewhere else. I don't actually really know where exactly. Depend node I added it. So this should work. So I've just seen that I used my own method incorrectly. Now it works. So the design has improved, you could say, because both of these things work. And this is how you would work in a test-driven environment. It really sometimes makes total sense to let the test direct your design, just to be sure you make it easy to use. And once you've done your test, you can write the implementation, starting at the documentation usually, because this really helps you to get a clear idea of what you actually want to do and what you want to achieve with your code. All right, this is already the basic workflow. So you wouldn't ever start Maya. I mean, you should start Maya at some point if you want to test UIs, if you want to click it yourself. But even for this, as we learned, you can use the UI testing facilities of Maya or of the MRV, which is, just as a recap, MRV Maya. If you don't want Maya support, you can say MRV no Maya, which is good because MRV will start up much faster, as it doesn't have to do a few things that it would do otherwise. And there are a few more flags, I think. that are useful for some situations that you can of course look up in the docs as well. One of them is MRV Maya Pi. Might be interesting on Windows, where the system interpreter likes to crash for pre-Maya 2011. That's my experience. So that's where you really want to use Maya Pi instead of the system interpreter. So the next, okay, this is how you would alter MRV itself, how you would add your own methods to it, your own customizations. Just as a little example, test anim, it just makes using, or it just helps to use the animation facilities that the Maya API has in a more convenient way. So that's all it does. It's more like a convenience wrapper, which is handwritten. So if you have a look at the actual implementation, then you see how it works. To override a default wrap, so anim curve by default is just a default node wrap, which is auto-generated, which just wraps the NFN functions onto the node type itself. But if you want to add your own implementations, we would do it like this. Just define a class which derives from the right subclass, and then you make your implementation. That's it. The next guy who instantiates the anim curve, or if you iterate through your scene and you get an anim curve back, then you will get an instance which is compatible to that one here. So you can make these calls and use it as you see it here. And this is really all it is about. You just put it in and implement it, and then it's in Maya RV. The next question would be, well, we have 3 minutes left, so we could quickly dive into the UI part, because UIs are very, very interesting in MRV. Okay, the code itself probably won't tell you much in the few seconds that we have to dive in there. So let's have a look at the graphical user interface documentation, which brings it, which is a bit more easier to grasp here. So it's object-oriented. You create objects of a window, for example, or of a layout. And let's skip all this to the interesting part. Events are very interesting. The way you handle events is fundamentally changed, because you can assign your events directly. So a button, you can say event released, and I want that function to be called. So this is all you do. And this is a super easy way to basically define how user interfaces work. And you can, of course, by the way, you can add as many functions to this as you wish, so they will all be called. There's not, in mail you have this limit that there's only one global mail method per basically event slot, and MRV works around this, and you don't even see it, you don't care about it, you just assign your callables and that's it. Custom events are called signals. Signals and slots, if you have ever used Qt, you will know the system. It's the same thing, it's just implemented in Python, and it's MRV's own system. It's probably much simpler than the Qt thing, but it's the same idea, so I call it signals. So here you see how we can define a signal, a custom sensor class which can react to the pushed, or which defines a pushed signal here. And well, time is slowly running out already. The last thing, the final conclusion of user interface is, together with signals and events, and the way you can easily assign this, and the way you can, as you see here, derive from existing UI types, all this together allows you to build totally modular user interfaces that don't care about each other, which is great if you want to have kind of black boxes like nodes in Maya that interact with each other, but they are UI elements. And there's, of course, kind of a parent script which connects these elements together, but then it will just work if you, of course, wrote your modules correctly. And this is something you can do with the default mail UI that is, below that wrapping. And that's very powerful, and together with the MRV features that come with it, all the node things and API wrapping, you have a whole new world of UI in front of you. See you next part, when it's about the template project.